everybody. I'm Sean. Today I'm going to explain about assignment part 2, which is work and energy and impulse and momentum. Question 1. Okay, so I'm going to explain to you step by step to solve this problem. So what we need to do at the first step, what we need to do is find the average. Okay, so the average of theta is theta 1 plus theta 2 plus theta 3, where all this information we'll get from part 1. Okay, we'll get from part 1, so which is 20 plus 30 plus 10 divided by 3, and we will get the answer of 20. Okay, next is x. X naught 1 plus x naught 2 plus x naught 3 divided by 3, where 3 of these are 0. So 0 plus 0 plus 0 divided by 3, and we will get the answer of 0. Same as y. Y naught 1 plus y naught 2 plus y naught 3 divided by 3, and 3 of them are 0 also. So we will get the answer 0. These are the average of theta, x and y. Okay, next we go for part 2, question 1a, free body diagram. So let me show you the free body diagram, how it's drawn. So first of all, free body diagram look like this. Okay, from A to B, and the height of A is 3.5 meter, and the object from A, so we got mg. Okay, so we got velocity vb and n. Okay, so next is the height of here, which is y naught is equal to 1 meter. Okay, this is the FBD, free body diagram of the question. So now we proceed to B. So the question asks us to find the speed of the object before it leaves the surface at B. So the object, the speed, the velocity of the object before it leaves B. So what we need to do, first of all, we take the formula from the question paper of this assignment, which is sum of TA plus sum of UAB is equal to sum of TB. And TA is the kinetic energy, which is M1 over 2 MVA squared, plus potential energy mgh, and equal to kinetic energy 1 over at B 1 over 2 mvb squared. So this is what we want to find, velocity at B. Okay, so let us put the value into it. So m we don't know, and v, velocity at A, which is 0, because the object is from rigid. Okay, so VA is 0 square, that's mean, and plus, okay, plus mg, m we don't know, g we know, gravity 9.81, and the h is 2.5. Why? Because the question asks us to find the velocity before it leaves B. That means the height, we need to neglect this 1 meter. That means 3.5 minus 1 is equal to 2.5 meter only, and 1 over 2 mvb squared. So as we know, this is 0. Okay, am I right? And the m and m is 0 also. Then we can take this over here. So after we take everything here, we left VB on the right, and we will get the equation of square root 2 9.81 2.5 equal to VB. So we get VB is equal to 7.004 meter per second. Now we proceed with question C, where the question asks us to find the distance from the wall of the ramp and B to where the object strikes the ground. That means the question asks us to find the object after the object leaves B, where it strikes the ground. We assume it as C. So we need to find the distance. Okay, distance we assume it as D. So first of all, we use the kinetic relations of x and y equations for horizontal. Okay, first of all, for horizontal motion. So we assume positives to the right, and the equations given is xc, which is d. Okay, xc is equal to d, and is equal to xb plus vbx times time bc. So let us substitute the value. xb is equal to 0 as we know, and vb we get from the previous question, which is 7.004 meter per second, and t cos, okay, 7.004 cos 20 degree. So cos 20, which this 20 we get from the average angle from the previous questions, and after that the time is the unknown time. Okay, so we get d is equal to, after we calculate this using calculator, and we get d equal to 6.582 with unknown of TBC. So next we proceed with vertical motions, which is we assume upwards positive. Okay, YC is this. Okay, YC. Okay, YC is equal to YB plus VBY TBC, and we minus 1/2 constant accelerations and t squared. Okay, so let us substitute the value. So YC as I said is this. So the height of this is 1 meter. So but we assume it upward, but the object is going downward, so it's negative. It's equal to YB is 0 plus, same as the object is going downward, so the velocity will be negative. Okay, so negative 7.004. So for vertical we use sine. Okay, sine 20 is the degree we get, and t is the unknown. Okay, TBC minus 1/2 constant accelerations is gravity, which is 9.81, and also t unknown TBC squared. Okay, it's TBC. And after we calculate all these things, and we'll get equations of in term of t, which is 4.905 TBC square plus 2.396 TBC minus 1 is equal to 0. Okay, we bring these equations in terms of t here, which is 4.905, yes, 905 TBC square plus 2.396 TBC minus 1 equal to 0. After after we calculate this, and we will get TBC. Okay, after solving this equation, we will get TBC is equal to 0.2691 second. So from here, we substitute it back to the equations. We get for D, which is D equal to 6.582 TBC. Okay, D equal to 6.582 TBC. We substitute TBC into it, 582 0.2691 second, and we will get the answer of 1.77 meter for D. Okay, last we go to question D, which is the last question for this question. So the question asks us to find the speed at which the object hits the ground. Okay. The question asks us to find the speed, the velocity of object when it hits the ground. Okay, hits the ground. What is the velocity? So we take back the equation, from the questions, which is sum of TA plus sum of UAC equal to sum of TC. Okay, this equation familiar, right? Because we used it in previous questions. So we substitute in 1/2 mVA square plus mgh and equal to 1/2 mvc square. And next we substitute the value 1/2 m. Okay, VA is 0 plus mgh is 3.5, because the question asks us to find hit the ground, means from the top until the ground is 3.5 meter. So we use 3.5 at here, which is m 9.81 and the height is 3.5. And then 1/2 m VC. VC is what we want to find. Okay, VC squared. So this is what we want to find. Okay, so of course this 0 and m we can cancel it. And after we move everything here, we will get the equations of square root 2 9.81 3.5 is equal to VC. So where VC is equal to, we solve this using calculator, we will get VC equal to 8.287 meter per second. Thank you very much. That's all from me. Hello, it's me again. We are going to do question 2, assignment part 2, question 2. Okay, now we proceed to the first question, velocity of object just after it rebounds. Okay, we want to find the velocity of the object after it rebounds. Okay, rebounds. So we substitute. No, we do it. Firstly, we do it using formula. So VCY. Formula is VCY bracket V1y square plus 2 constant accelerations SCY minus S1y, and we assume it as downward positive. This time we do it downward positive. So V1y is 0 plus 2 negative 9.81, and SCY, this C, okay, this C. So CY is SCY is here and S1y is here. So SCY is 0 minus 1. So we get VCY square, VCY1 equals square root 19.62, and VCY1 is equal to 4 Next, we use the formula of coefficient of restitutions. V ground 2 minus VCY 2 divide by VCY 1 minus V ground 1, and we assume this upward positive, and the coefficient of restitutions is given at the questions is 0.7, and as we know, velocity at ground 1 and ground 2 is equal to 0, so ground 2 0 minus VCY2 is what we want to find, and VCY1 is negative 4.4294. Why negative? Because just now we assume it downward positive. Downward positive, we get the answer of 4.4294. Now we assume upward positive, we'll get negative 4.4294, and minus V ground 1 is also 0. So we will get VCY2 is equal to 3.1006 meter per second. So next we apply the conservation of motions in direction x, x directions. We assume positive to the right, and mv1x equal to mvcx. So we can cancel the both m. So that's means v1x equal to vcx, and we know v1x is equal to 7.004, which we have done in question 1. That means vcx is also equal to 7.004 meter per second, which is to the right. Okay, therefore, the rebounding velocity of the ball is Vc2, which is equal to Vcx I, where it is for I, plus Vcy2 J, which is 3.1006 J meter per second. Okay, B. We want to find the maximum height to which the object rises after the first bounce, which is, we draw the diagram. Okay, the ball bounces at the floor, and the second bounce, what is the height? So we need to find this height. So we'll use the kinematic equations, which is Vcy 1 square equal to V1y square plus AC S2y minus SCY. And we assume it, no need to assume anything. So VCY is 0. From the slide told us that VCY at this position is 0, at this H is 0, so we substitute 0 at here, and V1y is 3.1006 square plus 2, constant acceleration 9.81 times this is S2y is displacement distance, which is H, minus Cy is 0. Okay, so Cy 0. Then next we will get the answer of 9.6137 plus negative 19.62 H, and after we move the H to here and everything, and we will get H is equal to 0.49 meter. The final height is 0.49 meter. Thank you very much. That's all from me.